Hi, I'm Curt Frye, and in this video, I'm going to start talking about Markov chains, and I will spend a little bit of time describing them before I show you how to use them in videos later in this playlist. So let's start with what is a Markov chain? Well, it summarizes a process defined by states, and the classic example is a simple weather system. We have three possible states: sunny, cloudy, and rainy. And the question is, how do we transition and how often from one state to another? If we're sunny, then 60% of the time the next day will be sunny, 30% it will be cloudy, and 10% rainy. If it's cloudy on a given day, then it's 20% likely that it will be sunny the next day, 30% cloudy, and 50% rainy. And finally, if it's raining, then the next day, there's a 40% chance of it being sunny, 10% cloudy, and 50% rainy. And if this weather sounds a lot like my hometown of Portland, Oregon, then you would not be far off the truth. We can summarize these probabilities in a matrix, and let's take a look at that weather transition matrix now. We go from sunny, cloudy, or rainy using the probabilities that we see here. So for cloudy, and this is the middle row, then 20% chance of sunny the next day, 30% cloudy, and 50% rainy. And the other probabilities are what I described before. This process never ends, but we can get a sense of what a typical day will look like by multiplying the matrix by itself 20 or 30 times to get the steady state or the typical values over the long run. So let's take a look at the transition matrix steady state. So the idea is that we multiply the matrix on the left by itself a large number of times, 20 or 30, and then we get the output matrix on the right side. And any one of the rows will give us the probability for any arbitrary day being one of these states. And reading from left to right, they are sunny, cloudy, and rainy. We can also look at processes represented by Markov chains and see how many steps it would take to move through them. As an example, let's take a look at export review, where a product you're sending overseas needs to go through a number of steps before it is released. There are 5 steps in this process, and it's possible to exit the process after step 5. That means that the probabilities don't always add to 1 because you can exit. However, we can use these values to calculate the expected number of steps. And, in fact, in later videos in this playlist, we will do exactly that. This process transition matrix might look something like this. You start at step 0, and then with the probabilities given, you will move to one of the other steps. So about half the time, you will move to step 1, 20% of the time step 2, and you can read the other probabilities there. Step 6, which again is outside of this, is when the package is approved and you can send it. So that is an overview of the Markov chain process. I hope you enjoyed the video, and if you did, please like it and subscribe to my channel. Hi, I'm Curt Frye, and in this video I'm going to continue my discussion of Markov chains. Specifically, we're going to use as our example a process transition matrix. The process we're using is steps for export approval to ship a package overseas, that is outside of the US in this case. Step 0, which we do need to include, is when a package is outside of the process and it needs to start the review. Then we have the next 5 steps, which are elements of the approval process. They don't all have to be done. Well, step 1 does, but all of the others could be optional. And then finally, we have step 6, where the export has been approved. And we do not model that because at that point, the shipment has exited the process. So the scenario is reviewing shipments before exporting. There are 5 steps. You exit the process after step 5, and step 5 could be done, or it could be deemed unnecessary, and the probabilities don't always have to add to 1 in each row because you can exit. And let's take a look at that transition matrix now. We start at step 0, and then half the time we'll go to step 1, and then step 2, 20% of the time. So sum 20% will go directly from step 0 to step 2. And then if we go down a row, we see that if someone is at step 1, then they will stay at step 1 30% of the time, move to step 2 30% of the time, step 3 30% of the time, and the other probabilities are there. The first 2 rows all add up to 1. However, below that, you can see that they do not. For step 2, which is the third row down, we have 30%, 20, 20, and 1, or 10 rather, and that adds up to 80%. So 20% of the time, after step 2, the package has been approved and can be shipped at step 6, which again is outside of our matrix. Now let's switch over to Excel and see what it takes to define a transition matrix there. I'm in Excel, and the sample file I have open is Markov movie 02, and you can find a link to that in the video description below. The transition matrix, which is referred to as Q in this type of analysis, appears here in the range from C8 through H13. I'll start by adding some labels, and these will correspond to the steps. So I have 0, 1, 2, 3, 4, and 5 up top. Those are the 2, or the destinations. And then here we have 0, 1, 2, 3, 4, and 5. And press tab to move to the right so I don't scroll down. I will change these labels later for a specific reason I'll demonstrate, but to make that demonstration work, I need to enter the values for the transition matrix into the worksheet cells. You will never end up at step 0 from any other step, so I will just type a 0 all through the first column, which is column C, and then I can start adding values for steps 1, 2, 3, 4, and 5. So from step 0, you'll go to step 1, half the time, 0.5, then 0.2, and I'm pressing tab to move to the right, 0.15, 0.1, and 0.05, and enter. Because I know this row needs to add up to 1, I will click in cell I8, press Alt equal to create an auto sum formula, and enter, and I get a total of 1, so that's good. However, if you were watching closely, you might have noticed a possible error, and yes, this is something that I will deal with in a moment. I'll go back to cell D9, and this will be for step 1. So you'll stay at step 1 30% of the time, 0.3. Move to step 2 30% of the time, also 0.3. Step 3, 30%, so 0.3, then 0.05 for step 4, 0.05 for step 5. And I'll press tab to move to I9 and press Alt equal, and then with my AutoSum formula in place, I will press enter. And the values that have been added up add up to 2. So let's click cell I9 and see why that is. The AutoSum formula includes the label in cell B9, so it's being added to my total. And this is a very common error, and it's the reason that you do not want to use just bare numbers as column or row labels. Instead, you want to make them text so they don't figure into this type of calculation. So in B8, I'll type step 0, and then click cell B8 after that's in, and then drag the fill handle down, and you can see that because there is a number, dragging the fill handle will increment it. So go from step 0 to step 5. And just to make it look a little bit better, I will center it, and then I'll do the same up top for the column labels. Step 0. I do want a space there in tab. Then after I click C7, I'll drag the fill handle to the right and center, and there are my labels. And now I can add in the rest of the values, and because I have demonstrated what's called a checksum, I can select cells I8 and I9, delete, and continue on. The values in column D for station 1 will all be zeros from here on, so just enter 4 zeros there. And then in E10, I'll start adding my new probabilities. So 0.3, 0.2, 0.2, and 0.1, enter. Then I'll have 0.05, 0.3, 0.2, 0.1. And again, these values do not have to add up to 1. And in fact, they fall far below 1. It's 0.65, it looks like. Then step 4 is 0.02, 0.03, 0.35, and 0.6, enter. And then 0.01, 0.01, 0.03, and 0.7. I entered the values into this transition matrix, even though I'm not going to do any calculations on them in this video, for a couple of reasons. The first is I wanted to demonstrate the possibility of an autosum error like the one I demonstrated earlier. Secondly, I wanted to give you an idea of the data that you needed and also how long it takes to enter it. This is essentially a 6-stage process. You've got step 0 all the way up to step 5, so that's 36 values that you need to enter. If you have a larger process, then it will take more time. With all that in mind, you can plan what you need, also understanding which data that you need, and from there, you can start to get to work. I hope you enjoyed this part of the analysis and explanation of Markov chains. If you did, please like the video and subscribe to my channel. Hi, I'm Curt Frye. In this movie, I'm going to show you how to calculate the expected number of steps that it will take to move through a process that has been defined using a Markov chain. The sample file that I will use is Markov Movie 03, and you can find a link to it in the video description below. At the top left, I have a transition matrix, which is by convention known as Q. The idea is that a product, in this case a shipment, needs to go through a number of steps of review, not all of them, but at least one, before it is approved for export outside of the United States. We start at step 0, which is when a package is outside and is ready to start review. And from step 0, you can go to step 1 half the time, 0.5, step 2 1/5 of the time, or 0.2, and the other values there. Once you move to step 1, then you have a 30% chance of staying at step 1, 30% moving to step 2, 30% moving to step 3, and the rest you see there. The last row, step 5, has probabilities of going back to step 2, which is 1%, step 3 also 1%, step 4 3%, and the probability of staying in step 5, which is legal review, for another step is 70% or 0.7. And again, these probabilities in the bottom rows do not add up to 1, and that's because some of the packages or shipments will have been approved, and those are outside of the process. Below that, I have the identity matrix, which is called I. The identity matrix is the matrix that will give you the original matrix back if you multiply it. So you can see that on the main diagonal, starting from the top left to the bottom right, we have all ones. And even though my rows and columns aren't the same width and height, this is in fact a square matrix. I have 6 rows and 6 columns. So from top left to bottom right, they are all ones and all other values are 0. And if I multiply this identity matrix by the matrix Q, then I will get Q back. Over on the right, I have 2 other steps. And the first step in this calculation is I minus Q. What does that mean? Well, it means that we are subtracting the Q, or transition matrix, from the identity matrix, and then we'll perform an operation on the result. Let's see what that looks like. I'll click in cell K9, type equal, and I want to subtract the elements of the Q matrix from the corresponding element in the I matrix. So I've got 2 matrices that I need to work with. I'll define the first one in parentheses. So I have the identity matrix, and that is C21 to H26, then a right parentheses, minus, then left parentheses, and Q, which is C9 to H14. Then type a right parentheses to end and enter, and there's the result. I have performed element-wise subtraction. So for the identity matrix top left, we have 1 minus 0, which gives us 1. And then going through the top row, in the second column, we have 0 minus 0.5 is minus 0.5. And the rest of the calculations are the same. So that is how we do the first part. However, we need to do one more step, and that is this thing here, which is the quantity I minus q to the negative 1. In matrix mathematics, minus 1 indicates an inversion, or the inverse of a matrix. I'm going to switch now to the inverse example worksheet to show you what that means. I have a small matrix here on the left, so 4, 3, 3, 2. And the idea is I want to find the inverse of it, and an inverse is the matrix that if I multiplied it by this matrix, then I would get the identity matrix back. To perform that calculation in Excel, I'll click cell G3, equal, and then the function we'll use is min-verse, so minverse, or matrix inverse. And the array is C3 to D4. Right parentheses and enter, and I get minus 2, 3, 3, and minus 4. So when I multiply the first matrix by its inverse, I should get the identity matrix with a 1 top left, 1 bottom right, and the other two values being 0. So I'll click in cell E6, equal. Matrix multiplication, mmult is the function. And first array, C3D4, then comma, then G3, and it's a spill. That's what the hashtag means, because it's the result of a calculation that's spilled, and enter, and I get the identity matrix back, as I described it earlier. One thing to point out is that not every matrix has an inverse. So if I go back to the ShipRev worksheet, it is possible that the quantity I minus q, this matrix here, does not have an inverse. And if that's the case, then you will need to change, even if only slightly, values in the transition matrix. It might be going up by 0.01, down by 0.01, whatever, just so long as you get an invertible matrix. So to find the inverse of I minus q, which I have stored here, I'll go to cell K21, equals, then minverse, and the array is K9, and the spill of the result, so it's K9 through P14, then right parentheses to close out the formula and enter, and there's the result. We can use this information to calculate the total number of steps by adding up the first row. So I'll click in cell Q21, press Alt equal to create an AutoSum formula, and enter. And it looks like it will take, on average, 6.32, call it 6.3 steps to move through this process. If, like me, you love popular mathematics, you might subscribe to the number file channel. And Professor Marcus du Sautoy has a terrific video on Numberphile where he analyzes the game of snakes and ladders, which is called Chutes and Ladders in the US. I have a link to that video in the description below. And in that video, he gives you a couple of different examples and shows you how to perform different calculations using a Markov chain. Thanks again. I hope you enjoyed this video, and if you did, please like it and subscribe to my channel. Hi, I'm Curt Frye, and in this movie, I will show you how to use a mathematical construction called a Markov chain to model how many bikes will end up at different stations at the end of a commuting period within a city. The sample file that I use is Markov Movie 04, and I have put a link to this file in the video description below. If you look to the right, you'll see that I have a map or a model of a bike rental system. There are 8 stations. We'll assume that the blue stations at the top are, in fact, in residential areas where people live, and then the three at the bottom, which are in gray, are places where people work. The idea is that this would represent the morning commute when people travel from their home or perhaps the end of a public transportation line to the downtown, and they choose to use bikes to do that. On the left, I have two copies of a transition matrix that shows where trips start and end on a percentage or probability basis. Starting in cell C4, a trip from S1 that comes back to S1, in other words, the bike is returned there, happens about 5% or one time out of 20. Going from S1 to S2 happens 3%, S1 to S3 5% of the time, and you can see the other percentages there. And again, our goal is to determine, or at least estimate, the number of bicycles that will end up at each of the stations at the end of this commuting period. You can do that by multiplying this matrix by itself multiple times. Sometimes you'll have to go up as high as 20 or 30 times if you have a large matrix. In this case, we can probably get by with less. So let's see what that process looks like. Now I can enter in my formula. So I'll type equal, and we'll do matrix multiplication. So that's MMULT. The first array is C4 through J11. And then, because I do not want this reference to change, I'll press F4, and that makes it an absolute reference. That's what the dollar signs mean. Then a comma, and I'll select the second copy of the transition matrix, which is C14 through J21, then right parentheses, and I'm leaving the second copy of the matrix reference relative, so it will update when we transfer the calculation. And I'll press enter. That is the result of the multiplication. So that looks good. Now I will click cell C23, press Control-C to copy, and I'm going to copy down the formula. And our goal is to continue multiplying, doing matrix multiplication, until the values in each column are about the same. And they will get pretty close fairly quickly. So I'll click cell C32, Control-V. There's another copy. I will press Control-C to copy that formula. Click below with one blank row or one blank cell between the cell I selected and the result above. Control-V. Going down, and it's looking like the values are starting to get pretty close. So copy cell C41, click in cell C50, Control-V. That's pretty good. Copy again, and C59, Control-V. Might not take too many more. Copy C59, click in C68, Control-V. And I'll copy C68. Click in cell C77, Control-V. All right, we're getting very close. I think I'll just do one more. So I will copy the value in the formula in C77, C66, Control-V, and yeah, that's looking very good. So what I can see from the result is that on average, we can expect about 3.7% of the bikes to end up at Station 1, 3.4 Station 2, about the same for Station 3. Station 4 will have 8%. Station 5 will have 10%, 0.099, rounded up. And then 18% for Station 6, 34% for Station 7, and call it 19% for Station 8. And again, these numbers represent the percentage of bikes that will end up at each of the stations at the end of this transition period. I hope you enjoyed this video, and if you did, please like it and subscribe to my channel. In the previous movie in this playlist, I showed you how to calculate the steady state or expected result of a system that has been modeled using a Markov chain transition matrix. You can do the calculations by hand if your company or institution doesn't let you use Visual Basic for Applications, which is the Excel programming language. but it's easier if you can write the script that you need. And in this movie, I will show you how to write a VBA macro that will calculate the result in a minimum of space. The sample file I'm using is Markov Movie 05, and you can find a link to it in the video description below. I'm looking at a bike share company or a bike rental company, and it has 8 nodes or 8 places where you can pick up and drop off a bike. 1 through 5, which are labeled here in blue, are in residential areas where people live. And the idea is that during this commute, which will be in the morning, from 5 in the morning until 10, most of the riders will end up in the business district where they work. And those nodes, 6, 7, and 8, are represented below in gray. And you can see the transition matrix has the probability of a bike going from a particular station and ending up at another. So in the morning, from station 1, which is here, 5% of the rides will stay at station 1, so the rider will pick up and drop off the bike at the same place, go from S1 to S2 3% of the time, S1 to S3 5%, and then you see that very few go to other residential areas here. And then, for the downtown trips, the closest to S1 is S6, so 36% go to there, another 35% go to S7, and 12% go to S8. And the other probabilities are distributed in the same way. So there are 2 things we want to do. The first is to determine the percentage of bikes that end up at each station at the end of the day, or at the end of this period, and also the number of bikes. So I have added in cell I13 the number of bicycles that are part of this network, and I've set it to 500. So the question is, how do we do the multiplication that we need? In other words, we need to multiply this matrix by itself a large number of times to get the result for the projected end state, which will go down here. And we can do that by creating a function in VBA. So I'll move over to the Visual Basic Editor by pressing Alt F11, and then I will insert a module, and I'll drag the code window up. Now in the code module, I can define my function, so I'll type function, and I'll call it steady state. And I will name the variable that we're passing in, vMatrix, as variant. And that's the only one we need, because we're doing our multiplications inside of Visual Basic, then we'll be able to use just the one value. So I will close the parentheses, press enter, and I get the end function statement at the bottom. And one thing I will note is that I'm moving through the VBA elements pretty quickly. And the reason is because I have an Excel VBA course on LinkedIn Learning, and I have to keep everything on YouTube separate, and also I can't compete with what I put on LinkedIn Learning. So if I go a little bit quickly on some things, it's because I've already covered it elsewhere. And I will give you a link to my Excel VBA course in the video description as well. So here I need to declare 2 more variables. I already have vMatrix as variant, so I'll do dim, which is the declaration statement, I as integer. That will be a counter, and then dim vResult as variant. And I'll use this to hold a second copy of the matrix that we read in. Now I can create a for next loop that will multiply the matrix we bring in by itself 30 times. So that'll be for I equals 1 to 30. And then I'll go down below and type next, and then an apostrophe or a single quote followed by an I. And the reason I'm doing that is so that I know which variable this next is connected to. Excel VBA lets you create for next loops where the next doesn't indicate which loop it's part of. And in this case, it wouldn't be confusing. However, if you have multiple loops, especially if one is nested or placed inside another, then it can be hard to remember, at least quickly, which loop is associated with what. So I always put the variable name as a comment next to the next statement. And I just need to multiply the matrix by itself. So, actually, before I do that, I need to say vResult equals vMatrix. So now I have the second copy of the matrix ready to go. So then I will multiply the matrix by itself multiple times. So I have vResult equals, and then we'll do matrix multiplication. And for that, we can use the built-in worksheet function. So that'll be application.worksheetfunction.mmult, which is matrix multiplication. And then I need to identify the two matrices we're going to use. So that will be vMatrix as argument 1, then a comma, and vResult. There we go. And then after that has been done 30 times, we should get a steady state, and then I can return the variable to the function. So I'll do steady state. I need to type in the name of the function I gave it above, equals vResult. Okay, everything looks good. So I will press Alt F11 to move back. And then I've already selected cell C16. If you haven't, go ahead and do that. And I will type in a formula using the new steady state function that I created. So equal, then steady state. And you can see a list of functions that are available. And one reason that I use camel case, that is uppercase and lowercase letters, is to distinguish functions I create from the ones that are built in. It just helps me remember. So steady state, and we're only passing one range, so that's C4 to J11, which I selected above, then right parentheses and enter, and we get the result. So at the end of this particular segment or time period, 4% of the bikes will end up at station 1, 3% at station 2, 3% at station 3, and then looking at downtown, station 6 will have 18%, 7 will have 34%, and station 8 will have 19%. Now I can multiply those percentages by the total number of bikes to find out how many bikes are at each place. So actually, I will select cells C24 to J24 and type equal, and then I13, which is the number of bikes, and I'll press F4 to make that an absolute reference so it doesn't change. Then asterisk to multiply, and I can use the value just above the cell that I'm in. So that'll be C23, and because I want that reference to change, I will leave it as a relative reference. Because I have multiple cells selected, I can press Control-Enter and enter the calculation in each of the cells. So this will be the number of bikes that end up as each of the stations. And the reason that I have 18.57, where I would expect with 0.04 to C20, is because this value is rounded. So if I select the cells in the result, that's C16 over to J23, and increase the number of decimal places that are displayed, and I do that on the Home tab of the ribbon in the number group, click Increase Decimal, and you can see that in fact I have 0.37, 0.372, continuing on from there. And of course you can round your values if you want. However, in this case, this gives us a very good idea of how many bikes are going to end up at each station at the end of this particular time period. One final thing, if you want to save your workbook as a macro-enabled workbook so that you can hold on to the function, you need to press F12 to save as, and then wherever you want to save it, I have mine on my desktop in an exercise files folder. Instead of type Excel workbook, click that, and then change it to Excel macro-enabled workbook. So that's there. Click Save, and now you can close and keep the function that you created for use in this workbook. I hope that what I've shown you here for transition matrices and steady states is useful. If you enjoyed it, please like the video and subscribe to my channel.